All right, so now let's go directly to our topic, which is unit circle. Okay, so now we are dealing with circle right now. So let's start by drawing a circle. Draw a very nice circle. Okay, let it be better than mine. But just draw a very nice circle that is better than mine. You can use a small cup if you want to. Okay, so that's my own circle. And start with a center of this circle. A center of this circle. And then you can divide this circle into two equal parts. So just draw a line that is horizontal through the circle. And that's, you can call it your x-axis. And draw another line that divides it. So this will be the y-axis. We're still dealing with unit circle. Okay, so now why is it called unit circle? It is called unit circle because the radius is 1.
Yeah.
The radius is 1. Any circle you draw that has a 1 radius, regardless of the unit you use in measuring the radius, is called a unit circle. It could be 1 centimeter, 1 millimeter, 1 micrometer, 1 kilometer, 1 mile, 1 yard, 1 foot, 1 whatever, inches, it doesn't matter, as long as the radius is 1. So you have a radius that is 1. Okay? Now, at this point, where you have this radius 1, there is the equivalent value of y. There's also equivalent value of x. So at this point, there is a coordinate that is established, which is x, y, at this very point. So what that means is that in this circle, you started at this point, you moved all the way, you created a unit circle, which is radius 1, and you created also an angle that is theta, unknown angle. All right, so what that continues to mean is that at this particular length, here's what I'm emphasizing on right now. At this particular length, you have x. At this particular length, you have y. So, I'm sorry, I made a mistake, sorry. At this particular length, you have y, which is equivalent to this y here. Then at this particular side, you have x. You have x. Okay, so if you like, you can redraw this small diagram, this small triangle that is created. You can redraw it if you want to. You can just redraw it like saying a triangle that looks like this. This is your theta, this is your x, this is your, this is your y rather. And then this is your x, and this is your 1. And of course, 90 degree is created here. So you have a right triangle. You have a right triangle in that case. You have a right triangle. Okay? So in your right triangle, once you encounter a right triangle anywhere, let 2 things come to your mind. Pythagorean Theorem and also SOHCAHTOA. Okay? So now let's start with the Pythagorean theorem. Let's start with the Pythagorean theorem. So now we are considering this triangle, or you can consider it from the circle. It's the same thing. I just you know. So let's consider. I'm going to write by Pythagorean theorem. By Pythagorean theorem, we know what that formula is. Can you, somebody help? What's the formula of Pythagorean theorem again?
A squared plus B squared equals C squared.
Okay, so A squared plus B squared equal to C squared. So already in this case, the C is the one, because that's the hypotenuse, right? That's the one facing the 90 degrees. So this is 1 squared. Now, look at this. Any of these can be A, any of these can be B. So you can have x squared plus y squared. Okay? So now what is 1 squared? 1 squared is what?
1.
1 squared is 1. And then on the other hand, you're going to have x squared plus y squared. So this very formula that we just derived right now, is the general equation of a circle. Just like you have a general equation of a straight line. So this one is what? General equation of a circle. In terms of the x and y, the square will not go away unless you are solving for x. If, for example, we are solving for x, that's when the square will go away, and then we can replace it by something else. Like, okay, let's just try to solve for x or solve for y. Let's just try to do any of those. Let's try to solve for y right now in this particular case, okay? So solve for y. Just see, so that you can see how the square can go away, if that's the right phrase to use. So we are solving for y. So solve for y. Okay, so the solution is going to be, so you have to transfer this to the other side. So you are going to have y squared is equal to 1 minus x squared. And then in order to obtain the value of y, so we are going to do square root on both sides. And the square root of 1 minus x squared. And so y will give us, square root of 1 minus x squared. That is if we are solving for y. And if we are solving for x, the same thing will happen, except that this side, inside the square root sign, will be x. Okay? So now, let's get back to the triangle, because there is something important that we need to get to, since we are doing trigonometry. Now, we have considered Pythagorean theorem, but the main thing we are about to do now will be to use trigonometric ratio, because once you have a right triangle, you either use trigonometric ratio or you can use Pythagorean theorem to evaluate something. So now let's look at the trig ratios. So I don't mind redrawing the diagram so that I can see it very clearly, and you can do as well. So we have y, we have x, we have theta here, we have 1 here. So now remember your SOHCAHTOA. I told you before, everything in trig basically starts from SOHCAHTOA before you start expanding to other areas. So now, using this SOHCAHTOA, now let's define the sides. Let's define the sides of this triangle. So the side that is facing the 90 degree, is the hypotenuse. The side that is facing the given angle is the opposite. So this is the opposite. And then the other side becomes the adjacent. Okay? So now, considering your SOHCAHTOA, sine theta would be opposite of hypotenuse, which is the same thing as saying Sine theta is what? Sine theta is equal to, opposite is y, hypotenuse is 1. On the other hand, cos theta would be, what is cos theta?
Adjacent over hypotenuse.
Yes, so it's adjacent over hypotenuse. Therefore, cos theta will be, adjacent is what? X. And then hypotenuse is what? 1.
1.
Okay. Now let's consider tangent. Tangent of theta is, tangent is opposite. Tangent is opposite over adjacent. Okay. So tangent theta is equal to what? Y over x. Is y over x. So now we have 3 trigonometric ratios now. Of course, any number over 1 is the same number. So this is equal to y. This one is equal to x. And then this one is equal to what? Y over x. Okay. So now look at this. Look at this. This is, you can call this one equation 1. You can call this equation 2. And you can call this equation 3. You see, equation 1 says that y is equal to sine x. Equation 2 says that x is equal to cos theta. So now let's make that substitution. So you can say substitute equation 1 and 2 into 3. Substitute 1 and 2 into 3. So what that means is 3 is tangent theta is equal to sine of theta divided by cos of theta. That's what that means if we make that substitution. Okay. So we have, by this, what we have just done so far, we have established the first trigonometric identity. So that, but let's prove this. Let's try to prove this using our calculator. Let's try to prove this using our calculator if this is correct. Let's try to do that using our calculator. So I am going to pull up a calculator right now, and then I will use real numbers to see if this is correct. Okay, so let me share a new screen. Okay, new screen. I'm going to share calculator screen. Now pick an angle of your choice, any angle of your choice.
75 degree.
Okay, so I am going to do sine 75 degree. Remember, I'm working in degree. Let me clear this. Make sure you are working in degree. Okay, so this is already selected to be in degree. So I'll enter and then I'll clear. So let me repeat. So sine 75 degree, hit enter. You see what it gives you? 0.9659. Let's do cos 75 degree. Let's do cos 75 degree. You see what it gives you? 0.2588. Now let's do tangent 75 degree. Let's do tangent 75 degree. Tangent 75 degree. Close the parentheses. Hit enter. You see what it gives you? Okay, now let's do sine 75 degree divided by cos 75 degree. Let's do that. So sine 75 degree, then divide by cos 75 degree. Are we ready to hit enter? Yes, so hit enter. Boom. See what it gives you? Is it the same value?
Yes.
Yes, it is the same value. It is the same value. So sometimes you may be given sine of an angle and cosine of an angle, and you'll be asked to find the tangent of an angle. All you need to do is, going forward, know that this tangent of that angle is exactly the same thing by just dividing its sine by its cosine. Period. End of story. So let's go back to the other screen. Let's go back to the other screen. Okay. You see, we started from here. This is our circle. We started from the unit circle. A unit circle has a radius of 1. And then we have our x, we have our y. By the way, in terms of degree, what is this degree right here? In terms of degree, this is 0 degree. This point is 90 degree. This point is 180 degree. This point is 270 degree. Then when you get back to the other place, then it completes 360 degree. Okay? I told you, ladies and gentlemen, I told you that this is the first trig identity. Trig identity. So there are other trig identities.